And at the bottom, we are going to do our review like we always do. It asks you to find the sum or difference for each problem. We're only going to give you about 4 minutes because you're only adding and subtracting, and then we'll go over them. Go for it. Okay, who can tell me what I need to do first for number 1 to add decimals? Mason? Line up the decimals. Okay. So 3 plus 7? 1 plus 6? 7 plus 7?
14.
Carry my 1, bring down my decimal. 1 plus 5?
6.
Plus 8?
14. 14.
Any questions about that one? Guys, I don't like talking over people. You better figure it out. All right, what about subtracting decimals? Do my rules change? No, I still have to line them up. 3 minus 7?
You can't do that.
So I borrow 5. I don't like talking over people. Thank you. 13 minus 7? 6 minus 6?
0.
Bring down my decimal. 8 minus 5? Any questions? All right, what about adding fractions? What do I need to do? They need a common denominator. And what is a common denominator between 7 and 5? 35. So what do I do to 7 to get to 35? By 5. So 3 times 5 is?
15.
And what do I do to 5 to get to 35? So 4 times 7?
28.
15 plus 28?
23.
Over 35, because my denominator stays the same. What kind of fraction is this? It is improper, so what do I need to do?
Make it a 5. Yeah. Turn it into a problem.
By doing?
Turn it into
By doing? What operation, guys? Somebody said it. Division. How many times will 35 go into 43? With how many left over?
8.
Over 35. All right, and 4. What do I need to do to subtract fractions? Somebody said it. Common denominator. And what is the common denominator between 3 and 4? So what do I do to 3 to get to 12?
4.
So 20 times 4? And what do I do to 4 to get to 12? So 15 times 3? What is 80 minus 45? And my denominator stays the same. My denominator is bigger than my numerator is bigger than my denominator. What do I have to do? Divide. How many times will 12 go into 35? 2, with how many left over? 11/12. Any questions about this? All right, turn the page. Is she okay? I'm going to go check on her. Hand it in for his pulse.
Okay, guys. This is one, this should be the one you're on, right? Return the page, Lucas. Of course, you were supposed to write stuff on the first page before you turn it. Guys, on this one, the double number line shows 3 equivalent equations. So just as we've done before, we've given you different equations. What I want you to do, write the equations represented on the double number line. What is the value of n that makes all the equations true? So there's our big question, what's the value of n? And how can you check that the value you determined in question 2 makes all the equations true? So how can you check it? So those are the 3 things you need to do. We'll give you guys about 3 minutes, because honestly this one shouldn't be too difficult. This one should have been pretty easy, guys, because they literally gave it to us. M plus 2 equals 3. N plus 5 equals 6. M plus 11 equals 12. Literally, all you had to do is find the pieces that were together on my double number line. Once I looked at it, who was able to figure out what value of n made them all true? Gavin?
1.
N equaled 1. How did you check it?
So I swapped the n with 1, and after I did the equation, I made sure that the solution was equal.
Good. So you just switch it with n in the equation. And then I say, okay, 3 equals 3. Check. Then we did, Jedediah, please stop. I've asked you multiple times already. Actually, you know what, Jedediah? This seat's empty. Come here. 1 plus 5 is 6. 6 equals 6. Our other one we said, m plus 1 plus 11 equals 12. 12 equals 12. Check. That's all you got to do, guys. I substitute the value that I find back into my equation and solve it and see if it actually works. If the two sides of the equation came out to the same number, you had the right solution. That's how we solve it. Is everybody good so far?
Yes.
Okay, let's go to our next page. When you determine the value of a variable that makes an equation true, you solve the equation. A solution to an equation is a value for the variable that makes the equation true. The double number line can represent and determine the solution to an equation. So if I have a double number line and it doesn't tell me what my variable equals, I can still use that double number line to figure out where I need to go to find the solution. So if I have an equation like x plus 10 equals 15, I can put that on my double number line. X plus 10 goes on one side of the barbell, 15 is on the other. Just like we've been doing, right? Is everybody okay with this so far?
Yeah.
Anybody struggle with how we did it? Okay. Now, to determine the value of x so that it is equal to 15, we can move the barbell 10 units left to find where x is. That means we subtract 10. Why? Because I'm going to the left. Okay? So x plus 10 minus 10 is x. If I just move the entire barbell by 10 spaces, I've now gotten rid of the plus 10, minus 10, just left me x. I take 15, I subtract 10, and what do I get? Okay? I moved the entire barbell 10 spaces to the left. So not only did I get rid of the plus 10 to leave x by itself, I also take the 10 from the 15 to give us 5. So how can I check that x equals 5 is the solution to the equation? How can I check it? You don't just know. How do I check it?
Undo what the equation is. So say x plus 10 equals 15, you just subtract 10.
No.
How do you even do subtract? You replace x with 5 and then you add to see if it's correct.
I take my equation, x plus 10 equals 15. I replace it with 5. 5 plus 10 equals 15. Does 15 equal 15?
Yes.
Which property of equality did we use? Really?
Yes. Subtract. Wait, but how do you subtract it to add? You just add it, but then you say the subtraction.
But what property did I use to solve it? I added?
Subtractive property of inequality.
Really? So Jedediah is saying this is the same as adding. That's what the minus sign means?
Oh. Subtractive property of equality. That's subtraction.
Yes.
That was the basic.
So we used the subtraction property of equality. We subtracted that same amount, 10, from both the equation and from the answer side to get to the solution. Does this make sense, guys? Do you understand why we're saying we use the subtraction property even though it said x plus 10? Because how did I undo the plus 10? I do the opposite, which is subtract. So the property I used was the subtraction property of equality. See it? Okay. Turn the page. So now we want you to use the double number line, determine a value that makes each equation true. Identify the property of equality that you use for each equation. Check your solutions. There's actually 3 things here. We need to use a double number line, actually 4, to determine the value that makes it true. We need to identify the property of equality, and we need to check our solution. I will just give you guys a warning. We already did this with A4 first period, and almost nobody is marking their text still after 3.5 quarters of asking you to do this. Every single student failed this page. Let's see if you guys can do better. I just gave you a huge hint. The marking the text will help you pass the page. Good luck. We've got 3 problems. You're doing A, B, and C. I'll give you guys like 4 minutes. Go ahead and start. Okay, this one should have been relatively easy because they only gave you one thing to do. So we have the P plus 10 is 17. So I start up here. P plus 10, 17 gives me my barbell. Would it be okay if I put 17 on top and P plus 10 on the bottom? It would be. But the way they've written it, I would have done it, set it up this way. So what do I need to do to my P to get it to be alone? Minus 10. So I'm going to the left to find P. And how far left did I have to come? Minus 10. So what am I doing to the 17? Minus 10. So that becomes 7. So determine the value that makes it true. P equals 7 makes it true. Did I use the double number line? Have I identified the property I used? No. What property did I use? Property of subtraction. The equality property. Subtraction property of equality. Subtraction property of equality. And did I check my solution yet? No. How do I do that? I go back to my original equation. I substitute the value I said. Let's try that again. P plus 10 equals 17. 7 plus 17 equals 17. 7 plus 10, 17 equals 17, check. If you did not do all 4 of those things, you would not have passed this problem. Okay? Our second one. We have 14 plus Q equals 32. So my 32 goes on the bottom. How do I get to where Q is? Minus 14. So I'm going left 14 to get to where Q is. And if I take 14 from 32, I get 18. So my solution is, not P, this one is Q, equals 18. We use subtraction property of equality again. Guys, you shouldn't be talking. You should be writing. And my check, I go back to my initial equation. 14 plus Q equals 32. I substitute my value. 14 plus 18 equals 32. 32 equals 32. That's a check. Our third one. We have 90, so now they changed it. They put the number on top. And we have x plus 64 on the bottom. How do I get to where I would find x? Minus 64, so it's going quite a ways. Because the opposite of adding is subtracting. So that's going to get us down to x. I take 64 away from 90 and I get 26. So my solution is x equals 26. We again subtracted, so we use subtraction property of equality. Because I look at what I did. I subtracted from both of them. Because it was adding, the opposite of adding is subtracting.
If it has that plus symbol, then it's subtraction.
Correct, because I have to undo it. It does, and we'll talk about that in a second. I go back to my equation. 90 equals x plus 64. Substitute. 90 equals 26 plus 64. 90 equals 90. Check. Guys, any questions on this page? Okay, let's go to page 417. We need our highlighters or something to mark our text. Highlighters would be best.
What about pencil?
Color pencil works. A pen would actually be okay. Guys, quiet down, please. So on this one, we have one-step equation is an equation you can solve using only one operation. So these are the simplistic ones we've been doing so far. The way we have been doing it is what we call inverse operations. Inverse operations are pairs of operations that reverse the effects of each other. So subtraction and addition are inverse operations. What would be the inverse of multiplication? Division. Make sense? So that's why we match these up. Basically, if I'm doing one thing, to undo it, I use the opposite operation. Okay? Which gets to where we had our notes yesterday, our last class. We also need to do this one. The additive identity property states that any number, m, if I add 0, it equals m. In other words, when you add 0 to any number, it stays the same. It keeps its identity.
Go ahead.
So this is actually the property that we are using as we're solving these. We just haven't actually said that yet, but I'll show you how in just a second. So to solve the equation h plus 6 equals 19, I can use the double number line to solve for h. How? I'm at h plus 6 and 19. To get to h, I need to subtract 6 instead of adding 6. So that brings me back to h and 13. To solve it, and here's the way we taught you to do it the other day. If you didn't earmark that page, I recommend you do until you get comfortable with the process. We circle our variable. We draw a line through the equal sign. I say, what number is with it? 6. What operation is it? Addition. So my opposite would be subtracting. So I'm going to subtract 6 from both sides. That actually gives me h plus 0. Because when I take 6 and subtract 6, that is 0, correct? By the additive identity property, if I'm adding 0 to h, I can rewrite that because I know that is just h. Because any number added to 0 gives me that number. Then I can check. If I do 6 minus 6, that gives me 0. I put in the minus 6, and I find h equals 13. So what is the solution to h plus 6 equals 19? 13. H equals 13. How do I check the solution? Good. So instead of h plus 6 equals 19, I write 13 plus 6 equals 19. Now I get 19 equals 19. Check. My solution checked. You know the really good thing about this, Jedediah? I'm actually going to like this. This is now your permanent seat. Because now I can just write your mom and say, please listen to today's lesson so you can hear how Jedediah is acting in class. Here's our big one. Which property was used to maintain equality while solving? What property did they use? The subtraction property of equality. Are there other solutions to the equation? Is there another number I could put in other than 13 that would make this true?
Yes.
Yes, what one?
You could put in like other. You could put in a math equation for h.
No. No, it says, is there another solution? Is there another number I could use for h other than 13 that would make it true? No, there isn't, guys. No. The only solution is when 19 equals 19. The only way to get there is to make h 13. Okay, so now we're going to give you guys a chance to practice. We want you to follow the steps if you don't understand the process. Circle your variable, draw the line, find the number with it, do the opposite operation with that number on both sides. And then check your solution. So you only have 2 of them to do. We'll give you guys like 2 minutes. Okay, everybody's back from lunch. You guys should have had this solved. Here is your strategy. Once again, in case you didn't write it down. First step, we circle our variable. Second step, we put a line through the equals. Third, I find the number with my variable. So Triton, what number is with the t? 24. Guys, stop. It should be really easy because my variable is circled and I have a line. So I'm saying what number is there with it. In this case, now I look at the operation. So what operation is happening? Plus. So the opposite would be subtract. So I do the opposite operation with that number on both sides of my equation. Why? Because 24 minus 24 is 0. T plus 0 is t. We just talked about that property. 85 minus 24 gives me 161. It also said to check our solution. So I now take my solution. 61 plus 24 equals 85. 85 equals 85. Check. Every one of these, the process goes the same. Start with circling your variable. Draw your line. Olivia could even answer this one. What's the opposite of adding 12? Oh, good job. So I subtract 12 from both sides. Gives me m. 35 minus 12 gives me 23. I substitute to do my check. 12 plus 23. 35 equals 35. Check. Questions on how we are supposed to be solving these? One-step equations are nice. It's only one step. I just have to figure out what operation is going on. Do the opposite operation. Okay, so we can use the same reasoning you've learned to solve more complicated equations. Think about each algebraic expression. Use reasoning to describe a relationship between C and D that makes the mathematical sentence true. Okay? This one is going to get a little tougher. Our solving strategy isn't necessarily going to work. Here's what I will tell you. What you need to do, pick a value for C. It can be any value because it's a variable. But once I have picked a value for C, that is going to lock in a value for D. So, Jace, give me any number. 2. So I am going to say C is 2. So I now have 2 plus 23 equals D plus 14. I'm now down to one variable. So now I can solve. 2 plus 23 is going to give me 25. What's the opposite of adding 14? subtracting 14. So now I can subtract 14 from both sides, and I get D equals 11. So when C equals 2, D equals 11. I can still check it. So I put 2 in for C, and I put in 11 for D. 2 and 23 is 25. 11 and 14 is 25. It checked. Does that make sense?
How does C equal 2?
We chose it. They didn't tell us what it was, but they said they want us to describe a relationship between them that makes sense. So the easiest way to do it is pick a random value for C, and then you can solve for D. You can do the opposite. You can pick a value for D and then solve for C, but you have to choose one of the two. But once you've made that choice, it's going to lock in what the other one is. Okay? So, that being said, you guys now, ooh, this is going to be fun. Why? Because I have a C on both sides of my equation.
Wait, does that mean this?
Okay? And on this one, I have 2 C's and 2 D's. Yes, ma'am.
What you gotta do is multiply.
You do, but you also have to add an additional C on this side. So this one, these C and D are going to be completely more complex. Let's see how well you guys can do it. So I'm going to give you guys about 7 minutes to try to solve B, C, and D. If you want to make it easy for yourself, I will just tell you make C equal to 2 for all of them. If you want to experiment, you can change. Do some with C, do some with D, whichever way you want to do it. There's going to be a lot of different right answers on this problem. Okay, so I'll admit I hadn't looked at this one first. If you use 2 for C, it actually is going to be a harder problem because you're going to end up with a negative number for D. So I'm going to use a bigger one for C on part B. I'm going to say C equals 40. So I can now say 45 plus 40 equals 66 plus D. So I now have 85 equals 66 plus D. Here's my variable. The opposite of adding 66 would be subtracting 66. Those go away. This becomes a 7. We have a 9. So we say D equals 19. If you did what I recommended, which was use C, it would have been 45 or 2. 45 plus 2 equals 66 plus D. So then I have 47 equals 66 plus D. We have that same process. Now I subtract 66. The problem is most of you don't understand how to take a number and subtract a number that's bigger. So let's do another integer operations lesson for you. If I am adding or subtracting integers, all I do is I look at the two of them. 47 is a positive. 66 is actually a negative because it's being subtracted, right? If they are different signs, I actually subtract the two numbers. So I take 66 minus 47 gives me 19. The big guy wins. The big guy is negative, so my answer is negative. So had you done what I said, your actual answer should have been D equals a negative 19. Okay? Now let me show you the check on that. 45 plus 2 equals 66 plus negative 19. This gives us 47. 66 plus the negative means I actually subtract it. So I would do 66 minus 19. I get 5, 17, 47. Does 47 equal 47? Check. That was my right answer. Okay? Now, guys, please be quiet. We don't have that much time left. Again, if I used C equals 2 on this one actually worked okay. I would have 2 plus 3D equals 2 times 2. So I would say 2 plus 3D equals 4. Here's my variable. The difference now is I actually have what we call a two-step equation. I am adding and multiplying on the side with my variable, aren't I? So I have to get rid of the addition first. So I would subtract 2 from both sides, which would leave me 3D equals 2. I circle it again. Now I'm going to divide, because 3 divided by 3 is 1. 1 times any number is none, is that number. D equals 2/3. If I substitute that back in, I say 2 plus 3 times 2/3 equals 2 times 2. What's 3 times 3 2/3? Well, I can pull that out. 3 times 2/3. Whole numbers go over 1. Those become 1, so that would equal 2. So that's saying 2 plus 2 equals 4. 4 equals 4. So my solution on that was C equals 2, D equals 2/3. Yes, sir. Hold on, guys. I called on one person. All you should not be talking.
Wouldn't it be easier if we made C, D, and D1?
Again, there's a whole multitude of numbers I could use.
Sorry, because you could do 3 times 1 and then 3 plus 3 is
Yep.
6, and then 2 to the 3rd power.
3 would work really well with that one, yes.
6.
Yeah. Yes, Christopher. Guys, I only had called on Christopher. Why are all the rest of you talking? Yes, Christopher.
On the second question, when you added 66 plus negative 19,
Uh-huh.
wouldn't that have meant it would be a negative because the positive and a negative?
No, because the positive number was bigger. That's the integer rule for adding and subtracting. I subtract the numbers because they're opposite signs, but whichever number is bigger gives the sign to the answer. That's why and on this side, when I did the subtraction, the 66 was bigger because it was negative. That's why my answer came out negative. When I checked it, now the 66 was on the other side. Now the 66 is positive. It was bigger, so I subtract, and now my answer is positive. See the difference? Okay? And then our last one. I think 2 will actually work okay on this one. So we did 4 times 2 plus D plus 10 equals 8 times 2 plus 2D. So this now gives us 8 plus D plus 10 equals 16 plus 2D. So I now have D plus 18 equals 16 plus 2D. So here's where we're getting into some really advanced concepts. When I have a variable on both sides, I need to get all my variables to one side and all my numbers to the other side. So I'm going to start by saying, here's 1D, here's 2Ds. So I'm going to take this one away first. So it's really the same property. What property did I just use? By subtracting D from both sides. Subtraction property of equality, right? Does it matter what number D is? No, because I subtracted that same number from both sides, right? But what has happened now, D minus D is still going to be 0. So I have 18 left on this side. But now I'm taking 2D and I'm subtracting D. So how many D's do I have left? I had 2 D's. I'm taking 1 away. So I have 1 D left, right? Now I can actually solve. The opposite of adding 16 would be subtracting 16. Those go away. I have D on this side. 18 minus 16 gives me 2. So in this case, C equaled 2 and D equaled 2. And just to give myself room to do my check, I can do 4 times 2 plus 2 plus 10 equals 8 times 2 plus 2 times 2. Order of operations, I'm going to do my multiplications first. 8 plus 2 plus 10 equals 16 plus 4. 8 plus 2 gives me 10 plus 10. 16 plus 4 gives me 20. 10 plus 10 is 20. Does 20 equal 20? So, did my solution work? Yes. That was actually a really complex problem. Hopefully you guys were able to follow through on that one. Okay, we're almost out of time. I want everybody to go ahead and turn to your homework. So go to page 421. Guys, this is not a time to talk. Go to 421, quietly open it up. Pay attention because I'm about to give you some very good hints. On the first set, we're going to use a double number line to solve them, and we need to check our solution. Does it say to identify which property you use? No. Do you have to? No. Would you be in trouble if you did? No, that would actually be okay. Extra work is never bad. But I do need to put this on the double number line and then solve for x. Put this on the double number line, solve for x. Put this on the double number line. Notice we have a decimal. We haven't really done those yet. I will give you a hint. It may be helpful for you on this one to actually solve it before you put it on the double number line. Okay, this one. Now they've thrown a fraction and a mixed number in on you. Again, shouldn't make a difference. If you're following the rules, you'll know what to do. Here's where it's going to get a little trickier because they've given you a lot of mixed numbers.
Guys, quit talking while he is talking.
And not only do we need to solve, we need to check. So you've got 6 of them to do here. And they're giving you now decimals as well as fractions and mixed numbers. But if you will follow the process, it shouldn't be hard because you're not having to mentally solve it, guys. Follow the steps. It will tell you exactly what to do. Then all you're doing is the math. And all of them should work out okay because they put the bigger number as a solution, so you shouldn't be getting into negatives in any of these. Yes, sir? Okay, I will put the steps on the homework in case you guys missed them. You can go back. Step 1, circle the variable. You guys can go, just realize it'll be on the video if you need it. Step 2, draw a line through the equals. Guys, quiet please, I'm still recording. You too. Step 3, find the number with the variable. Sorry about all the noise in the background. They're moving on to their next class. And step 4, do the opposite operation. With that number, that's operation, sorry. Operation with that number on both sides. Okay, guys, good luck. Take care.